In the heat of the moment, you don't have time to think about balancing equations. But that's exactly what's happening inside your airbags. A lightning-fast chemical reaction that protects you from harm. Want to know how it works? We're about to crack the code of balancing chemical equations. Let's hop into a PhET simulation and see what we can do. Before the simulation, airbags are life-saving devices. What might happen if the right amount of stuff is not in the airbag when an accident takes place? Well, the airbag might not inflate properly, and then it's not going to help us at all. Now, use the space provided in the chemical equation to balance the reaction inside the airbag. This can seem a little daunting, but remember that the subscripts tell us how many of that atom type there are. If there's no number, that means there's one. Let's go ahead and just start by making one of each molecule or atom. Looking at this, I can plainly see that there are not enough nitrogens. There's 3 on one side and only 2 on the other. I'm going to go ahead and start by adding another one of our reactants. I'm going to add a second sodium and 3 nitrogens. Now I have an even number of nitrogens on the reactant side, which is going to make it a lot easier to balance out the even number of nitrogens on the product side. All right, let's jump into the PhET simulation. So first, I just want you to click on the link and get into the introduction option. Here, don't be too worried about balancing chemical reactions. Just click buttons and see what you can figure out. Great. Now that you've taken some time just to play around and see what you can do, let's talk about each of the buttons. Box A is all about our reactants. So every time we click the up arrow, we are shown the different atoms and molecules on the reaction side. In box B, there are 2 different tools that will help you see this balancing in even more of a visual way. Moving over to box C, we have our products. Here, when we click the up arrow, we add additional products. We've kind of already talked about this, but here, D, this is where these arrows add or remove the different atoms or molecules. As you are balancing, it's always a great idea to just go ahead and start with one. You have to have at least one of each product and reactant for the reaction to even show up. Box E is our reset button. Hit that orange at any time to reset back to normal. Down here in box F is where we have the different reactions that we can choose from. So these are the reactions that you will work with in your investigation. Great, now you know how all of the buttons in the simulation work. Time to jump into our investigation. Fantastic! You finished the investigation. I hope that you're starting to feel a little bit more comfortable with this process. Let's move on to the next portion, which is game time. You are going to show your skills and try to beat 3 separate levels. Pick a starting level depending on how you feel. Level 1 if you're still really shaky on this whole idea. Level 3 if you're like, psh, I learned this last year, no big deal. Good job with game time. I hope you're feeling proud of yourself for getting some of those done. Five, big idea. How does balancing a chemical equation help scientists and engineers in designing systems like airbags that involve chemical reactions? Scientists and engineers balance the chemical reactions that they work with, meaning that they put the same number of each atom type on both the reactant side and the product side. And the whole reason that they do this is to make sure they have enough of the ingredients that they need in order to make whatever they are making function. In the case of our airbags, we need to make sure that we decompose enough of our sodium iodide to form our gaseous nitrogen, which is what inflates our airbag. Thank you for sticking with me to the end of this PhET simulation. I hope you're understanding balancing chemical equations just a little bit more. You can always hop back into that game to freshen your skills.